we're going to assume that temperatures are normally distributed. Assume that coffee temperatures apparently that's what they're serving. I don't know. I don't know what burns them out. I don't know. I wouldn't think 100 would be too hot for 98.6 degrees body temperature. That's only 2 degrees. I don't know. I would think yeah, but it doesn't boil till 212.
Yeah, but you don't boil.
Well, I know. That's not even close to boiling. I don't think that's bad.
Alright, tomorrow.
Celsius.
Tomorrow I'll take
Oh.
of my
Okay. All right. Now, what?
What is the program T interval?
I'll get to that. Okay. Listen now, this is what you need to look at when the test comes and all the questions are mixed together. You need to know what you're finding confidence interval for. I'm finding the confidence interval for population mean. Tomorrow it's going to change, and the next day it's going to change. We've had 2 sections where we're dealing with population mean. What was the difference between yesterday's section and today's section? Big sample, little sample. What do I have here? Small sample. So that means I'm going to deal with T's instead of Z's.
So it just depends if it's under or over.
Yes. Now if it's under 30, which this is, there's one more thing I have to look for to see if I can even do this problem. What else do I have to look for in the problem? That has to be normally distributed to move on. If this line was not here, I would not be able to do this problem.
What if it's 30?
Greater than or equal to 30 is big. So under 30 is small.
What would we do if you had a small sample?
Didn't know this, you'd say, no, I can't do it. You cannot do statistics on something on a small sample.
Will you ever try to trick me?
Yep. Pretty much going to guarantee there's one on the test.
So we
Why?
can't do it.
Yes, you would say can't, if this line was gone, you'd say can't do.
17.
So, population mean, there's big sample, small sample. Small sample, I need to know one more thing. Normally distributed, now we continue on with our 3 steps. So by hand. First step, identify mean and standard deviation. Do I have those? Mean is 162. Standard deviation is 10. Okay? Well, there we go. Cold coffee we're getting here. Okay. Before I can find big E, we've got to find we should probably put that up here. Let's find the critical T-score right in step 1 also, so that when we get to step 2 we're ready. So go back and change this. Find your critical T-score. So, use the table, see if you can figure this out on your own. Use your MT if you've got that. Find the critical T-score.
Wait, what is the DF?
You look it up, I'll look it up. We'll compare our answers. I got 2.131. Those of you that are sitting there doing nothing, you deserve to not know how to do that.
Hey, is B above I don't?
Yes.
Is DF DF?
No, what is DF?
I don't know, that's what I don't get.
Oh.
N-1.
It's N minus 1.
Why is that like?
So I do.
What?
Why is
No,
that
it's
one?
sample.
I don't know that.
Oh, wait.
I have no idea the Stats World set that up to, I have no idea. Ashley,
I do that.
use my T table.
So how do you know what number it's
Confidence level across the top.
So we don't have, what's the, why do you minus 1?
Because I told you to.
Well, you didn't write that down.
I did in example 1.
calculator has that program.
Some.
Mine doesn't.
Mine does not. Okay, are we good? Ashley, find it?
Yeah.
All right, moving on.
It's a little lighter though.
Now we're ready for big E. Big E is that critical t-score we just found, times by the F, divide by the square root of the sample size. What was my sample size? 16.
Not n minus 1 or anything.
No. Only when we look up the table. I don't know why. Like I said, my stats background is this big. Why that table is set up, I have no idea. Can't answer that at all. E, let's go out 3 like the book's been going. There's our max error. So then we make our interval. It'll be the mean of 162 plus and minus 5.328. And this is what I would expect the average for all restaurants, their coffee temperature to fall in between. So what's 162 minus that 5.328? 156 point, and then 167.328. If you fed me the right number there. I can do the adding, I couldn't do the subtracting very well. Well, that's because that's all they told me. I can only write down what they tell me. Like I said, I can't subtract them. I know it's got to end in, what, a 2? I'm going to throw a 2 down there for funsies.
It ended in a 2. You're right.
Okay, that's your by hand process. So the only added extra is the T, and then again, be looking in the problem for things that tell me, yeah, I understand why this is a small sample problem. Okay, the program, actually run program now. Okay, we're going to do the same problem. See if you can run your T interval. We all have T intervals. We don't all have IMT, but we all have T intervals.
Oh, weird.
Same place we went yesterday. That. Over to test. And look down for T interval.
Okay.
Number 8. We have the stat. What's my mean? 162. What's my S? 10. What's my N? 16. My confidence level? 0.95.
It did it. Mine didn't do anything.
Hit enter.
Mine has a line going up.
Where's my calculator, like 30?
It's done. It just took a little while, because the T's, it's got to look up that T, it's got to calculate a T by it, so it takes it a little bit longer to do it. Okay, you do have to know how to do it by hand, so on the test I will have, there will be one from each section, one by hand, one by program, one by hand. All good. Okay. I gotta look, I gotta turn the page. Oh, not quite. Okay, now that we've got both things going, there'll be a section of problems where, listen, I'm not going to make you find all the intervals. All I want you to do is tell me whether you should be doing the Z or the T. So I'm going to give you a little flow chart. So, confidence interval or population mean, mu. Should I be doing Z or T? That is the question. Okay, I'm going to give you a little flow chart to help you decide. What do you think the first thing you should look at in a problem is? I said that right. N. If N is greater than or equal to 30, what do? Do the Z. Automatic. If it's a yes. If it's a no, that means we have a small sample. What do we look for next? Nope. Is the population normally distributed? Do you know what I mean by making that graph? Okay. If the answer here is no, what do? can't do. Can't do it. Nothing. If the answer is yes, there's still one more thing I forgot to tell you. There is a way to have a small sample and still do a Z. Let's throw that little. There's two things here. If they give you the population standard deviation, or do they give you the sample standard deviation? If they give you the population standard deviation, even though we have a small sample, you can still do a Z. So a small sample doesn't automatically mean T. If you only know the sample standard deviation, then you do a T. Okay, so let me show you what the difference in the standard deviations would be.
So it's less than 30, and it doesn't say that it's only distributed. Does they assume that, but they give you the standard deviation population of the sample, then you can't do it?
You can't jump past this step.
Go ahead.
So what did you ask?
Oh, wait, that is a yes. Never mind.
Okay. All right. Because that flowchart should answer all your questions. Let's see. Number 21 here, just take a look. It says in a random sample of 70 volts. Oh no, I don't even want that one. I want a small one. Right here, 22. You took a random sample of 15 two-slice toasters and found the mean price was $32.53. So we've got a small sample. And the standard deviation was 1945. Assume the prices are normally distributed. So I've got my small sample. I know the prices are normally distributed. Now I'm down to picking out the standard deviation. Is this standard deviation here, because they didn't use symbols, they used the words, is that an F or is that a sigma?
I think it's
Why do you think it's an F?
because you took it from the random sample.
It's referring back to this sample of 15. This is an F here. Because it refers to the sample, so that makes this an F. As opposed to, let me see, is there one in here? No. I don't see one. No, that's a sample. No, they don't even give you one, they should, but they would say somewhere in here, it is known that the population standard deviation is, so they will actually say it, population standard deviation. It'll be in the phrasing somewhere. They'll say from past studies or whatever. Well, it doesn't say sample standard deviation in here because it's kind of implied in this sentence that it's coming from this sample of 15. Correct. I would think that would be safe to say.
If they give you the mean deviation, but it doesn't say that's normally distributed, you still assume it's normally distributed because it gave you a mean and a standard deviation?
Nope. Nope. Okay.
How could they give you a standard deviation?
From a sample, if I took a sample of 5 things, I could find the mean and standard deviation of it. Doesn't mean it comes from a normal anything. Okay, so your assignment.
Only got like 10 minutes.
Water is water. This is all something.
Alright, good.
Water and salt is.
Yay!
Yeah,
Yep, not all.
Chris, this is literally like Texas.
Like, what a problem is it?
Why do you
Stop
think
complaining.
they're the same ones that she already wrote down?
That's 13 problems.
That's rough.
There's 13 problems of it.